tasty meats. That was dumb. Can I... Maybe? Oh, we can do this. Okay. Oh, let's not bust. Please don't get mad at me, Yang. Can we? No. Want my gun back. Fine. 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 This is fine. It's all fine. Pardon? Well, that's just like your opinion, man. Meat. What is going on here with these bombs? It's so bad with placement. That's that's what's going on. Criminy. Get a little bit happier music here. Thank you, Monty, for your service. Hey, we pulled it off. Boop. Okay, that was the thing. I see a key, I see a door that I don't know how to handle yet. Where is the seeker? The Jet Eye room. Okay. Oh, good, it's a gun room. Huzzah. And that's where that. Okay, we good. We good. You go. Here. Yes, yes. 1, 2, 3, 4. Come back, come back. Shoot. Okay, that'll work. And then go up here. Just some stuff. Okay. Okay, okay. You are gonna get sacrificed to Callie. Doop, 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 doop. Wait. Gotcha. There we go. Yeah, let's just go. Gun, gun. Not boss time yet. Shit. That could have been a lot worse. Now it's worse. Okay. Last run. And then I suppose we have to do that whole teaching thing, huh? What? Whatever. Yes. Thank you. You are my sacrificial dung roller. Hey. Hey, that's not how this is supposed to work. It's supposed to protect me from that mean thing. Ah, rumph. Yep. Yep. What's up? Yeah, sure. Let me do this. Okay. Thanks. You too. All right. Okay. It's pretty much class time. Now we're doing speedlunky, not speedlunky. The pregame for last class was writing Python code. This. Okay. You stay over there, please. 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 Thank you. Doop. Let's see what we can get out of this. Nothing good. Alright. Boss time. 5 minutes. Perfect. I want to go left. Or do I want to go right? I still haven't figured out the left path as much. Hurry up. Yes, go that way. Okay, so you switch when I bop you. Come on. No, no. Yep, there we go. Boop. Hey, bombs too. Doop. Teleporter we do not care about. And no insta-death, please. Thank you. Sorry, Monty. You go over there. Please. Yes. Now I'll be happy if you just get pummeled. Good enough. On we go. 3 minutes. Perfect timing. Nothing over here, but I do kind of want... Oh, no, we don't want to do that. All those spikes. I'm scared of that. Going down. Hey, a cape. Kinda hate this setup here. Let's just do that. I already had sticky bombs. Alright, that'll work. You got anything for me? 3 minutes. So good. Alright, don't care about you. Come on. Come on. Ow. Oh, kill him, kill him, kill him. Yes, good spider. Come on. Come on. There we go. We have Monty. Leprechaun. And not enough ropes. Monty can hang. Jedi still. Ooh. Alright, nothing, nothing. Alright, away we go. Ooh. This is why we wanted the cape. There's 2 exits. What does that mean? Does that mean this is a... Yep. Okay. Where are you at? There's one. One further down. Is it over here? I saw you open. Oh, it's so harder than the original. So much stuff. R.I.P. me. Well, in any case, it's a good good time to die, I suppose. Top tier content right there. Shame. I got to the City of Gold last night too. Today, I don't even know that I made it past the jungle. Oh, no, I was in Olmec earlier. So much new stuff to learn. Alrighty. Let's get going. So by now I'm going to assume that you all saw the Blackboard announcement that went out. So just a heads up for you all. I kind of promised this earlier on, and I just want to make sure that everything's going okay with you technology-wise. That you're okay with like the Twitch stream. We don't see Kirby anymore. See the Kirby anymore? Oh, yeah. Next week. So we decided to try and flip my. This is normally where my daughter does her online school. So figured we'd try it a little, see what it's like down here. But I think she likes being down here a little bit better. It's a lot quieter. My 10 a.m. class gets to hear my youngest have his 10 a.m. temper tantrum. Trying to minimize child screaming on cam. But again, it's an easy form of birth control to hear other people's kids screaming, I think. But that's probably a bit too much information. Anyway, so the survey, the one that is up there right now is just for my benefit. I'm the only one who's going to see it. I will toss a handful of extra credit points your way if you do it. Basically, it's just how's everything going? Do you like the format? Would you like something different? Just for my own, structuring of the class and make sure that everything's good for you all. The one that is coming on Monday goes to the department chair. For all new faculty, I guess you have to do it at midterm to make sure that, again, you're kind of happy or upset with me, whatever your feelings are, but that would basically be kind of like a midterm review of my progress. So look for that to come soon. That's a official one. Mine is unofficial. But just kind of a heads up. That's what all these surveys are, and it just kind of was accident that they're both happening at the same time, I suppose. But feel free to be honest. I mean, I'd rather honesty and constructive criticism. When are we doing the midterm presentation for our project? So that'll be the last week in October. I don't have a firm date yet of which I would like to do, but I will probably either over the weekend or early next week, I'll put out everything you need to know because I know that is coming up in 3 weeks, basically. The highlight is basically I will ask you. So I'm not going to have a hard number on how much completed has to be done. So I will say that. what I'm going to be looking for is kind of a status report in a way. So I haven't crystallized on paper what I want you to exactly deliver, but I'm going to be basically looking for, maybe a short little demo of where you're at. And if you have no code, I'd like to see what you're going to be doing. Um, I mean, it'll be kind of a show us some of your models, show us any prototypes you may have. Um, what have you done? What do you have left to do? That kind of thing. Kind of like a status update in a way. And that class, we will do it on Blackboard so that you can all present, basically. You don't necessarily have to put together a video. I suppose you could if you wanted, but we would do that one live, I think. Look for more details soon, basically. It won't be as much of a headache as a midterm would be. Let's put it that way. So that is all the administrative stuff. So hopefully the lab on Wednesday went well for you all. It was kind of a kickstart into the next phase of your project materials. So hopefully it was good. Again, if we were in class, we would have done like a whole class day where, I walk around and see how you're all doing with your materials and maybe do some initial constructive criticism type stuff. So that's about where we're at. And as you can see today, I'm doing something I don't normally do. I'm wearing a vest. Lab isn't, yeah, so yeah, Wednesday was a kickstart to get it going, and then you have a week and a half to get it done. Yep. I put enough meat in there that you could probably have gotten it done in class, but I wanted you all to have time if you needed it, basically. So, vest day, I had a suit coat on earlier and realized that I was going to be way too warm, and I really hate wearing suits. So you get a nice little dress vest, which means I am in project manager mode today. And you all will be as well. So this picture of a bird here I've got on the screen, this nice massive beak. You might be asking yourself, why is he showing us a picture of some birds in a nice lake? And the answer is that Unsplash Images, the little plugin I use in Google Slides to make nice, pretty slide backgrounds, this is what it had for project management. So I think we can all take something from this image, obviously. It has no bearing on it whatsoever. But what we're going to do today, we're not going to get through the whole thing. We're going to take a step back from our developer role. We are going to become project managers basically today. And what do we care about? We care about staffing our projects. We care about project timing. We care about what deliverables and what activities have to be done. So basically, you are organizing the project. And if you have plans to become a software developer, this probably is going to sound absolutely horrible to you. I know it does to me. I'd rather not be a manager if I could avoid it. But if this is something that you are interested in, going up the corporate ladder, basically, this is the kind of thing that we're going to have to be doing when you get to that point, right? How do you know how to put people where? How do you know when a project is completed, when the activities are completed, so on and so forth? You're going to need metrics to track that, basically. It's not just I think we're done kind of thing. We have all of these things which have to be checked off. This is the view from the upper level, right? We've been doing our software processes. We've been doing our, limited UML diagrams, right? We finished off with use cases. We did our requirements solicitation. We're going to go back into that after we get through project management and all that. But this is kind of a nice little segue into the flip side. Right, we've developed our use cases. We have, kind of an idea of what activities have to be done. We know what our clients want, what our customers want at this point. Now we can start really putting together a plan. How are we going to get our team to successfully deliver stuff? So that's what we're going to talk about today. Now, when it comes to looking at progress, right? So projects should have progress. You get that lovely EA sense of achievement, right? How do you move forward? Things you have to consider is that you have to know what the purpose of the project is. You have to know what your customer wants. You have to know what their requirements and what their needs are, and basically, are they going to be happy with what you're developing? And this is something you have to know up front because that informs, again, requirements, UML diagrams, implementation, all of that stuff. So clear communication at the outset is absolutely key. And we can take these and we can make it part of our tracking. All right. So with that, let's say that we know what our customer wants. Customer, again, external or internal, doesn't matter. It's whoever is fronting your project, right? You have to figure out for each activity that you design or that you kind of specify, how long will each of those take? How much will each of those cost? And as a whole, you can get a feel for what the length of the project will be, right? You're all working on your term projects. That's your big project for the semester. You know that you have one semester worth of time to get it done. Every activity that you're planning, how will each of those stacked up, either in parallel or sequential? Will that be hit the end of the semester? Will it go beyond? Right? So figuring out how much time everything's going to take is kind of a very helpful step in planning out your time, right? And with that, how much is it going to cost? For you all, it's obviously the cost of a semester, right? But if you are a project manager, you have to staff the projects, you have to get the right people on board, you have to pay for technologies, whether it's hardware or software or licenses or anything like that, right? What are the costs going to be at each phase of the project? That tells you if you're over budget or if you're under budget, if you're right on schedule. These things all kind of come into play here. So the schedule that I'm talking about, what is it exactly? You all develop schedules, and I know a good chunk of you actually do calendars for when all your due dates are, which is wonderful. It's good to be planning ahead. This project schedule is really driven by our software development cycle. So all of those different strategies we talked about way back when, this is where we can actually take each of these steps, plop it down onto a effectively whatever schedule strategy we're using. If you're agile or waterfall, you would use different ones. But this is where we take these stages of our project, right? Requirements elicitation, implementation, testing, whichever phase we're looking at, that can actually be an item in the schedule. And kind of the key word for today is we're going to refine these activities. We're going to decompose them into smaller subpieces. And then basically every single task will have a time and a cost associated with it. And how we kind of move them around on the schedule is going to be when things get done, what people get assigned to it, and so on and so forth. Other things we can get out of this too are the dependencies or interactions. So let's say that you're working on a video game project. If your team wants to develop a system where you can add enemies and non-player characters like villagers or something like that, well, you can add that in, but first you need an engine that can support that. Right? Whether you're doing like Lua scripting or you're reading a file of information, or if you're just randomly generating them, step one has to be done before you start adding people in, right? Adding entities in. So this notion of dependencies is actually going to play here. The other thing too that I should mention before I get too deep, this is not limited to software as well. So everything that we're going to talk about today comes out of other engineering fields, really. So think construction, think hardware engineering, basically any kind of a project can follow this approach. And actually, some of the things we're going to talk about today come right out of like chemical engineering and construction. It's kind of interesting how these all work across the various engineering disciplines. So, first and foremost, let's say that we want to start making a schedule. The thing that we started with was understanding what our customer wants, right? To figure out what our customer wants, usually it's good to figure out what deliverables they're looking for. So do they need a set of documents, right? So test cases or test suites. Do they need requirements? Do they need design documents? Do they need plans of implementation, right? So what do they need? This would be considered a deliverable. A deliverable can also be like a prototype, right? So I'm showing you my stepwise progress to our goal. Here's a deliverable, right? Sprint 1, the deliverable is functioning prototype. Maybe it's simply showing that a function is doing what it should. Could be a very complicated function, right? It could be doing some kind of nifty machine learning on a data set, and you're getting a valid answer out of it. Well, if you're at that point, that could be a deliverable, right? We have working AI. That would be something that we could show the customer, hey, we're moving along. And based on all these deliverables that we have, we can set milestones. Now, a milestone is basically a point in your project to where you are moving on from that activity, right? So activity A, develop an AI, its milestone is passed because we have delivered our project at this point. And we'll get into some more detail on this as well, but we should first probably talk about some of these terms. So first thing we have here is an activity. This is a generic construct for something that has to happen, right? Key notion here, it is a thing that takes place over a period of time. So an activity has a description and it has a duration, basically. So the milestone is then going to be that this activity is completed. Again, it's going to have a time frame for this. When does activity 5.1 have to be completed by? All right, what is its milestone? We also can have precursors, and all you really have to do to think about this is consider it to be basically like dependencies, right? So what has to happen before this activity starts? You could also call this preconditions or dependencies, or it's going to have a different term based on what your frame of reference is, but basically what has to happen first, all right? And then we have two more kind of key ideas here. So we have the duration. That's how long an activity will take, right? So if I say that I need 3 months to develop this AI, because I need to learn TensorFlow, I need to, maybe do some kind of a neural network or what have you, right? Whatever I need to do to get this activity done, it's going to take me 3 months. That's the duration. However, activities can also have due dates. So consider that I need 3 months to make this AI, but it's due in 1 month because that's when the customer said it's due. We have a little bit of a problem here, right? Because now we have something that has to be done sooner than anticipated. This is a failure in planning, basically, right? This activity should have been scheduled sooner so that, I had my 3 months to work on it, maybe a little bit of slack time to nail down the details or fix any problems, and then my due date comes along and I present it. Something which, if any of you are into the whole gaming scene, duration and due date is often where we see products released when they're not ready. So pretty much any Bethesda game, it seems, or any EA game. But these are two similar notions, but very, very distinctly important. All right, so let's talk about actually breaking this project down. So I have some kind of a project, and I talked about earlier that the keyword today is going to be decomposition, right? So all that really means is that I'm going to take some high-level project. I'm going to break it down into phases. I have my hopes now that Windows bought out Bethesda. Hey, you know what? That is a good point. I'm really hoping so too. No matter how buggy their games are out of the gate, at least they're still fun. Right? I had a blast playing Fallout 3 and Fallout New Vegas. I'm going to pretend that Fallout 76 hasn't existed yet because I've heard bad things about it and I don't want to sour my Fallout expectations. But the key here is that we are decomposing things, right? A project is very, very high level. Develop Fallout 5, for instance. What are the phases? Requirements elicitation, project design, implementation. Was Fallout 4 any good? I guess why I'm going through this. I waffled on buying it. Um, we break the project down into steps. So what steps do we need to get through this phase? Again, still kind of a high level category. But then we get into our actual activities where these are very specific things that have to happen. Once all of our activities hit their milestones, so all of these say activity 1.x is completed, step 1 is completed. You liked it a lot, good. So the only reason I asked is that I bought Fallout 3 and Fallout New Vegas on basically launch date, and I realized I probably should have held out for like the Game of the Year edition when all the DLCs were plopped in there, because I don't think I've ever played any of the Fallout DLCs, because I never wanted to buy them separately. But yeah, maybe I'll check that one out when a good sale comes along. Anyway, so when's phase one done? Well, when all these steps are done. How do we know when the steps done? All the activities are done, right? So each of these things will have a milestone that we can say, okay, check mark step one is done. Check mark step two is done. If we're done with all our steps, phase one is done. Move on to phase two. Or you can parallelize things. Maybe you can run activity 1.1 and activity 2.2 at the same time. Just depends on the people that you have, right? So again, we are decomposing our model into simpler and simpler steps. In this figure here, where do we put a tree like this in the project file? So this would basically be, it'd be like a simple activity diagram. So this is kind of a functional model in a way. This is not a formal UML construct, though. This is more of a nice little graphical visualization for, an upper level person to demonstrate. We're going to have variations of this coming up here too pretty soon. So again, project planning is not limited to software engineering. You can do this for any project, right? Anything that you want to do. So here are milestones for building a house. First thing we have to do, hey, we have to complete a land survey, right? Can we actually even put a house here? What's that in our terms? That's almost like a feasibility study, right? So do some of the early things here. Activity or milestone 1 to 2, we need permits. I have surveyed the land, I'm ready to buy it. I need a permit to build. Well, crap, this is zoned for commercial, not residential, so I can't build a house, I have to build an office building. So getting through all of these milestones means that we can move forward in our project. So this kind of a table here, this lists out everything that has to be done. The fall of 76. I will have to check that out. Sounds interesting. I really love like the various like video game retrospectives and historical videos and things like that, and kind of breaking down where things went right and wrong. Those are always fun to watch. But yeah, so milestones. We can break this down even further, right? So here we just listed out our milestones. Here we can actually break down our phases, break down our activities. Basically, again, simplify and decompose. Can we check off this? Can we check off this? Can we check off our phase, for instance? So let's say that we have our permit, everything's good. We're going to do some landscaping here, right? So phase one is landscaping, very high level. Step 1.1, clearing and grubbing. Activity 1.1.1, remove trees. What happens when you remove trees? Well, stumps are left over. Then we remove the stumps. And then, hey, after we get to that point, we have to seed and get the ground ready for growing grass, right? And after that, let's aerate the soil. Let's disperse some seeds out. Let's water and weed them, right? So basically, we're going through all of our steps here to actually get the land ready to build a house. So phase one, phase two, phase N, right? We can basically break them down into achievable things. And one thing I would like to mention for this too, you kind of feel like you're making progress when you do this in a project, right? If I am checking off, checking off everything, I can actually show that we're making forward progress, right? Whereas if I just do this all in my head, and maybe I feel like I'm not moving, maybe I'm spinning my wheels and not making any real progress mentally. If you have a breakdown structure kind of like this or any of the other ones we're going to talk about, and you start ticking off activities, ticking off steps, you actually feel progress, right? You can demonstrate that you are moving forward. So this kind of thing, not only does it help for project management, but it even helps like employee morale and things like that, right? You're showing forward progress here. All right, so let's actually start demonstrating what these look like kind of in a figure-based form, right? So we've been looking at tables. We've been breaking things down kind of in language and verbally and all that. Let's actually be able to show what has to be done, and we can take that and communicate with our other collaborators, right? Same thing as before. A picture will be a lot more demonstrative than a raw list of words. So here is an activity graph, and this is a very simplified version. Again, this is not a formal UML thing here, but here we have a list of the activities and what order they have to happen for this, build a house example. So we're going to start our project. We're going to do our survey, and we're going to request our permits. these can basically be done at the same time, right? So we can put them next to each other here. But 1.1, 1.2, these are going to point to our actual activities, right? So we can go back and reference activity 1.1, 1.2 here, right? So the lines here are basically showing our relationships from activity to activity. So we get through some of the more procedural, sequential things. Then we get to 2.2. 2.2 splits off into 2.3 and 3.1. What do these numbers mean? It's just your internal lingo, right? But we can add plumbing, we can install electrical, we can install interior plumbing, right? We can bring in other people into the project who can work in parallel, and we can still keep making forward progress down this graph at the same time. And then our project gets completed ideally sooner, right? And I'm not saying just throw engineers at the problem to be the byline. You add people just to make it get done quicker, and you actually go a lot slower, it turns out. But this kind of a diagram honestly shows you what can be worked on in parallel. Take that, like this diagram here, or this figure, you don't necessarily know what can be done at the same time. I mean, you can go through and figure it out, obviously, if you read it. But you look at a diagram like this, it's very clear, right? I can take this, and in 5 minutes, I can convince a project manager to loan me his, plumber, for instance, for the week. So figures like this tend to be very, very powerful, not only for communication, but just for simplifying things. So this figure's nice, it's great. However, it doesn't tell us timing, right? So one of the things we care about is how long, how long is excavation actually going to take? How long will adding interior plumbing versus exterior plumbing take? Right, so how long to run lines to add a hose versus add all the sinks and kitchen stuff that you need? We can add that to our activity graph. Why not? Now we've taken the wording out of what these activities are, just left the IDs, right? We can point back to our figure over here, 1.1 survey, right? So 1.1 would be survey, 1.1 would be survey. But we can add like how many days, weeks, months, whatever your unit of measurement is. And I would recommend if you're going to do this graph, add a legend so everybody knows what you're talking about, right? Circle is an activity, filled circle is a start or a finish. A line with a number on it is months or days or minutes, just depends on your project. But here we can see, hey, it's going to take us 15 days to get a permit and only 3 days to survey. All right, is there anything else maybe we can be doing while we're waiting for that permit to start? Or we get our permit done first and then we move on. It just kind of depends how you shuffle things around. But here you can actually start seeing where your time sinks are going to be. You can see how much time and effort is going to be required at each milestone, right? And you can take that and directly translate it into into your activity table from before, right? So here's our activity. It's going to take us 3 days to survey the land. Our milestone will be that our survey is complete, right? Getting the permits, that's the activity. It's going to take 15 days because you put in a request, it has to go through bureaucracy, and then in 15 days, hopefully you get a permit. Your milestone is that permit has been received, right? So we can start lining things up, figuring out who works on which task, when, and how much it's going to cost as well. Okay, so that was a kind of a simplified view of things, honestly. We're going to start talking about a few of the different methods for measuring this now. And I will say that this will depend on which software development process you're following. If you're doing something like waterfall, you might use things like Gantt charts, and we'll talk about that in a few. But if you're doing Agile, you're going to go Scrum or Kanban or any of those, you're going to think Gantt charts are the worst thing in the world. Why the hell would we even consider using that? And you'd be right. They do not work very well for Agile. But there are other methods that you can use to kind of supplant those. So the first one we're going to talk about was actually made in, I believe, the 40s, came out of DuPont, so the chemical engineering company. Also very commonly used in the construction field. So this critical path method, or CPM, not clicks per minute if you're an advertising person, critical path, this is basically tracking what is the longest amount of time your project will take for all of the critical milestones. And you work kind of backwards to figure out which activities can kind of be slotted in that don't necessarily impact that timing. The key here is that you're trying to figure out, in a way, you almost start with worst case, and then you try to figure out how you can not impact that worst case. So another interesting thing here too, if you think that sounds horribly boring, this is what they used on the Manhattan Project, back in the 40s. And that's why it was considered a success, because they had a structured progress like this. So critical path, kind of interesting. So minimum amount of time that it will take to complete a project by looking at basically the worst case here. So what is most critical? You can actually go through your list of activities and figure out, based on length of time, based on difficulty, so on and so forth, what has to be placed where in your project, right? So we have some notions of time here. So we have the real time. This is where it is how long an activity will actually take to do, right? So this is where you, the engineer, who's probably may or may not have watched Star Trek, where you quote double the amount of time that you need and then you do it in half the time and you look like a miracle worker. It's the bastardization of the quote. But this is what you say how long an activity will take, right? It's going to take me 3 months to build that AI. I could probably do it in 1 month, but I'm not going to tell you that. But that's the actual time. The available time is how long in your schedule you have for that activity. So two different sides of the timing coin. Real time is how much it's actually going to take. Available time is how much you realistically have in the project to get it done. This is where things like crunch time or overtime or anything like that's going to come into play. Do not just throw people at a problem like this if you have a, there is some separation basically here. More people increases real time. So then we have real time, we have available time. If we have a difference here, there's going to be some slack time. Basically, this is, if you've gone above and beyond, you have extra time to play with, you can focus on other tasks. This is also known as like float time, if you're familiar with this or not. So I'm going to show you a figure which should hopefully kind of clarify this a little bit. We can figure out the critical path of a project because there's not going to be any slack time at a node. Basically, along this path, there's no slack time. You can have more than one critical path, where the one I'm going to show you here in a moment has two critical paths, actually. And then slack time is just going to be the difference between available and real. So here's a figure, shamelessly ripped from Wikipedia, and actually the next slide has some Wikipedia quotes on it as well. It's actually a very good Wikipedia page for explaining this technique, if you want to go into it. I've got it on this slide here. But here we have 5 project milestones. So this is milestone 10, milestone 20, 30, 40, and 50, right? And on the transitions here, so this is going to take 3 months, this will take 1 month, this will take 3 months. This will take 4 months, this will take 3 months. So basically, here's how we get our milestones achieved, and basically this kind of in order. Right, so here, and this is, if you're looking for the details, this is called a PERT chart. It's something used in CPM. There's a methodology, whole methodology behind this as well. But we have 2 critical paths. And again, I was kind of saying earlier, it's your worst case timing in a way. So here, to go from 10 to 20 to 50, 4 months plus 3 months is 7 months. Going this way, 3 months plus 1 month plus 3 months, again, 7 months. So we have the same amount of time to go from here to here to here as we do here to here to here to here. Right, so our critical paths are going to be B to C or A to D to F. So we're going to have a similar critical time here. What's going to happen then is this path E is going to be considered subcritical, right? Because if we went from 10 to 30 to 50, that would only be 6 months. We would then have a slack of 1 month, right? So if we take 6 months, then we still have an extra month to deal with here, right? So what you can do is you can plan out your project. What are the most critical milestones? How long are they going to take? And kind of work backwards to see where you could slot in, like activity E, for instance, right? Because it's going to take 7 months to get here anyway. Can we work on this in the interim at some point? Now, obviously, it's got to be between or like after milestone 30, based on how these dependencies are drawn. This can get a lot more complicated, don't worry. We're going to look at it from a simplistic view because that's as deep as we're going to go into CPM. But things that we care about, and again, if you're interested in CPM, check out the Wikipedia page. It's one of the few wiki pages I recommend where there's a ton of information about it. So, what do we care about? We want to know all the activities to complete the project, right? Make common sense. We need to know everything we have to do to get it done. We also need the time everything's going to take, the dependencies, and what our milestones are going to be. Milestones. Didn't add an R there by accident, I hope. So, you look at this list, and this intuitively is everything you need to know anyway, right? But it's critical for the CPM method. Critical path method. Critical path method. Yep, I did do that. Okay, that's one way to figure out project planning. We have another way. Have any of you ever seen a Gantt chart before? This is the thing that you get when you use Microsoft Project, for instance. So this is an antiquated view in a way of project planning. This kind of a model assumes that everything is hammered in stone before you start planning things out. So our requirements are set in stone, and we're not going to necessarily need to go back and change them, right? We can set hard deadlines for every single activity that we have, and we'll be okay with that. I showed this to my grad student class, and they all laughed at me for showing it because this is not used anymore. It is used, though, in waterfall-esque project development cycles, right? This would go hand in hand with something where everything's hammered out early on. Because if we can start planning, and basically, again, these are all our activities, start, stop, maybe some extra slack time if we need, and the deliverable on here, again, we can kind of go through in a tabular form, see how everything lines up. First we're going to do our review our specs, we're going to review our budget, review our schedule, and then develop our plan, start going into our design. Activity A follows activity B, follows activity C. Maybe we can do some parallel development. But you get a nice kind of top-down view here, right? The danger with this model is that if your requirements change or something changes, your schedule easily gets thrown off, right? So this is not always a good thing. The other problem, which tends to happen with less than ethical people, it's very easy to go back in here and update some deadlines. And this is the jaded, crotchety old engineer in me. I don't know how many times I've seen like this value slightly get extended when the revision goes in because it turns out we needed extra time. A little change here, and this whole thing gets thrown out of whack, basically. But the key here is that it is actually a very useful tool if you want to at least get a head start on things, right? When I started my PhD several years back, I had just come out of the automotive industry. I was going to be the person that budgets my time. I'm not going to be that PhD student that goes into exponential levels of stress because I have so much going on. I've got everything regimented and budgeted for time. I'm going to do this today, this tomorrow. I'm going to work on my implementation the next day. I've got it all planned out. My chart went out the window after week 1 because it was just too much was floating all over the place, right? So take this and go to an agile environment or a spiral development pattern, right? We can kind of work this in here, but it's going to be so flexible that it's going to be hard to keep this thing up to date, keep it to task. One thing I want to show you too, if you do like this kind of diagram though, again, Microsoft Project is one of the tools that you can use. There's also this thing called Lucid Chart. There's a ton of charting technologies out there, but you can build your own Gantt chart pretty easily if you want. So like I was doing one earlier for the game that I'm working on. And to show you where I'm at with this, I started adding tiles. Oops, I added tile-based movement. I need a little debouncer here on my arrow keys, but my duckies are kind of moving around. My dogs are following the player. Everything's supposed to be grid-based movement. Um, how do I actually model out what I need to do next? Well, the ducks move nicely. The dogs are still following me as a vector, not a nice grid movement. I also need to make a scrolling camera. So for this week, I need to fix doggos. My next task is going to be add scrolling camera. Right, makes sense. Two easy tasks. Just requires some coding effort. Maybe Monday and Tuesday I'll work on the dogs. Just Wednesday I'll work on the camera. Right, I can very easily start parceling out my time. And then as you start adding, you can end up seeing where your delivery date will be. And again, let's say that this camera, I thought I could do it in a day. It takes 2 weeks because I'm bad at math or something like that, right? So then everything else underneath this needs to get kind of shifted, right? So now these, oh yeah, let's select everything. That's a good idea. So let's see, task 4, task 5. Can I not multi-select? Guess not. I don't use Lucidchart too much. But like for instance, this now is over here, this is now over here, this is now over here, and then you see my project ballooning in time, right? So that's kind of the whole reasoning behind diagrams like this. Let's budget out our time, and if we start going over time, well, there's a problem and we have to rectify it. Good so far, I hope. A couple more things to talk about and we're almost done. So one other thing that we can consider, in addition to pure timing and milestones, is who is going to be working on the project when. So for that, we can use basically a simple histogram type of thing. If you've never seen a diagram like this before, I'm sure you have. Maybe you don't know exactly what it means. If you do, great. But basically, each of these bars are separate entities. So here, like we are under load, here we be overloaded. I like this figure a little bit better to demonstrate. Here's how many designers we need, how many developers, how many testers, at which point in the project. So you can start planning out where people go. If you are the project manager, you generally will have the access to move your pieces around to get your project to be successful. All right, so let's pretend this is months, not days, to make it look more like this figure. So months 1 through 3, we're going to be doing our requirements design, right? We're going to be talking to the customer. We're going to come up with all of our UML diagrams, all the stuff we've been doing so far. Well, for that, we're going to need more designers, right? We're going to need systems analysts. We're going to need the people who can actually spec out the project. Once we get towards the end of that, excuse me, we start bringing in the developers. So here, okay, first and foremost, we need, let's say, 4 designers in our first couple of months. Then we can start scaling back. Maybe Professor Eric, the developer, gets moved to a different project because we need to start ramping up over there. But we have an extra space, so let's start bringing in our developers to get coding going. And then bring in more developers. And then bring in more developers. Maybe we need to add some testers because we're at the point where we can start validating our code, right? So what these little boxes mean here, so here I've got 4 people. Here I've got 3 designers, and you can actually see this in this table here as well. So 3 designers and then 1 programmer. Total of 4 people, but this bar chart can be broken down a little bit to show more detail, right? So if you need to ever communicate, this is basically like a 3-dimensional graph, just kind of projected into 2D. But this is one of the things you, the manager, would do to show where people are working in the project at what time. All right, let's contrast this with our Gantt chart or our activity model, whatever we're using to show progress. Activities 1.1 to 1.4, this is all systems analyst work, right? So we're going to need more analysts in these first 4.5 months. Get into design. okay, we still need analysts, but we need to start bringing in programmers. And then we get into implementation, all those things I just said. You can match people to activities. With people comes salary and benefits and time expended. So basically, you can even start thinking of things like budgeting as well. Because if you go over budget, then you get into deep shit, right? Told you I don't have a filter and I make no apologies. So this is the other side here. So this is the budgeting aspect. So how much have you spent on your project at which point in time? Generally, you will need to do some kind of a projection or an estimate of the project will cost this month at this month, this much at this month, the project will cost this overall. Here's kind of where we project our costs to go, right? And what you would typically do, if you're one of the people involved with the budget for the project, let's plan out this is what our costs are going to be, right? It's how much we're spending. So we expect this kind of a rate of expenditure. And then we can actually show what we actually spent, right? So here, the Google's covering it up, but in January, we spent a crap ton of money. Well, what caused that? Well, we needed to bring in an extra consultant because nobody in our team knew how to do TensorFlow or something like that. Or we needed something. We have an unexpected cost. But then, as things go further on, we actually do pretty good, right? We stay under budget and we go over budget again. And the point is that with a view like this, you're trying not to go too far over budget or too far under budget, because then you get into business related problems. So just basically another view that we have to look at here. The thing I'd like to end with is the new style of kind of project management for timing and all that. This is more of the agile approach. So it's the burn down and burn up chart. Any of you in the stream hear of that before? Curious, because I know some of you have like interned or worked in industry. This is kind of the more common one. Nope, okay. Well, at least one of you doesn't know it. This is what my grad students said they all use in their jobs, because most of them are, employed locally. But here we have kind of two different views, and it's very interesting. So these figures show the exact same thing from different perspectives. And that's kind of why it's interesting is basically what we're going to talk about here. So the burn down chart is showing you how much you have left to do. So this y-axis here is basically just number of tasks. It's something that has to be done, right? So let's say we have 12 tasks at the start of the project, or 10 tasks. So we're showing how much work is remaining here. The burn up chart is how much work have you done so far compared with the scope of the project. And why I said this is really interesting, this is one of those things where depending on which figure you show, you can convey completely different information. All right, so let's strictly look at the burn down chart. I'm putting my hand over the burn up chart. We're not looking at it right now. So here is how much we have remaining to go. So look at January through February here. We have no change in our work left. What does that mean? It means nothing got done. Same thing here, April through June. We have a flat line. There is no slope, right? There's no basically rate of descent, no velocity, I believe it's called. Why are we not making any progress in April, May, and June? Like, what's going on with our team? Are they just sitting there doing nothing? Talking about Fallout, right? Why have we not moved forward? So if I just showed this chart, a manager will look at this and see, well, what the heck was going on these 2, 3 months, 4 months? And then we see the same here. This is a simplified view, can be misleading. Let's look at the burn up chart. Well, if we look at this, our completed work is actually constantly improving, right? So we have more done, more done, more done, more done, more done. We have a little bit of a flat line here, but more is getting done. What is the disparity? Because again, these are showing the same data. Well, let's look at the scope. Hey, between January and February, the scope of our project increased, yet we are making progress. So when you look at the burn down chart, nothing got done because the net calculation of effort means that we increased our work. So our engineers spent the time kind of taking care of that fire, right? So things got done in terms of the scope they had. Same here from April to June, right? April to June, our scope rises significantly. Here it looks like a flat line because nothing new got done, but our team is still making progress. So the thing to basically consider here, and this is a takeaway for any kind of communication, make sure that the chart that you're showing is conveying the right information. You can look on the internet, burn down versus burn up charts. There are a ton of arguments about what is better, to use one or the other or both. It's kind of amazing because, Agile is so still relatively new and interesting that people are arguing what's better, what's worse. I mean, to me, if I were a manager, I'd rather see both because then I have the full picture. So, with that, we will end class today, and I hope you all have a wonderful weekend. Does anybody have any questions on what we talked about today and the assignments? Anything else? I can finally get out of this very uncomfortable formal vest for the day. It's my joke for you, all of you. It shows you my sense of humor. Very dry and bland. Nope. Okay. Well, no questions, thanks. All right. I hope you all have a lovely weekend, and I will see you all on Monday. And yeah, that's about it. Have a good weekend. That's your homework. Plus the thing due Friday, but having a good and relaxing weekend is more important, I think. So, bye everybody. See you next time. Thank you, thank you, thank you, thank you.